I see a lot of seats being empty. We've been talking about AI and we've been talking about ML a bit, right? I mean, I wear a lot of hats now. I'm one of the organizing committee. I'm one of the engineers with pgEdge and also the founder of Open Source DB. Now, I'll get all of your focus onto the base of database engineering / database administration at this point of time, right? We have had our own AI, I think our chunk of AI is for now, right, for the morning, satisfied, I would say. And we'll get into some of the database administration stuff, right? So what I'm going to be talking about is what are some of the use cases for multi-master replication, right? A brief about myself. My name is Kiran. I've been doing databases for the past 18 years. Databases is the only thing I know. I don't know anything else. So I certainly have some flair for it, though. Right now, I'm a database engineer at Open Source DB, pgEdge, and we are also working with DBTune. I've done the roles as a database administrator, engineer, and integration analyst with companies like GE, Oracle, and Enterprise DB, Second Quadrant, and stuff, right? I've been speaking a lot, and we have been conducting meetups, Hyderabad PostgreSQL meetups, and talking at PGConf India has been a norm every year. And yeah, so that's about me. Let's get into the actual agenda that I had in place, right? So what we are going to be talking about is looking at multi-master replication, how it is different from some of the conventional systems that we have built, we have deployed at our enterprises, right? Most of them being a single master, or most of them being one primary and then bunch of read replicas being set up, right? For us to understand multi-master replication and then look at what are some of the use cases where we will be able to deploy these solutions, right? Where we will be able to look at even starting a project on a multi-master replication, right? So I'll talk about a couple of customer use cases that we have built off late, and also take a sneak peek into what are some of the solutions that are available in the current Postgres ecosystem. So whenever we look at any application or any database system in place, right? Any database system in place, what do we have? These are the 4 use cases that you would look at, right? You would need high availability. All your databases should be up and running. All your applications should have 99.99, 4 nines and 5 nines availability, right? And another important thing is the low latency that we wanted to have, right? Low latency is to make sure your users are interacting with the database. Your application is able to go ahead and give the resultant set in a far more brisk way, in a far more brisk pace, I would say. And then the couple of other use cases we have are the geographic scale out, which is to make sure I have one database server which is available in the Europe region. I would like to go ahead and set up an India region or a Singapore region. And then how do you do it with accuracy? How do you do it hands-free? How do you make sure the multi-cloud is also available, right? And then another important thing is the data residency, right? With GDPR, right, we have had tons and tons of data residency requests coming through, right? So in GDPR, if you take only that, the data needs to be processed within the whole Europe. Apart from this, there are other use cases also for multi-master, right? You would want to have closer to the user, edge computing. Sandeep mentioned about edge AI, right? All of these are also part of your multi-master use cases, but we will focus, for today, we'll look at these cases and see how well we can address them, how well we can use some of the products that are available in the Postgres open source ecosystem. And then one other important point is, if you are on legacy systems, right? IBM is a legacy system, right? And then you are on an Oracle 11s or 12s, you are on a legacy system, right? So we are looking at grabbing those legacy systems and modernizing them, right? So whenever we say database modernization, we talk about, hey, I would look at latest and greatest of that specific database platform, right? If you are on an Oracle, you will look at 23C, right? If you are on a Microsoft SQL Server, you are an Azure shop, you will look at the latest and greatest available on the SQL Server, right? Right now, what we are looking at is how PostgreSQL could be adopted from a modernization standpoint. Not only moving to cloud is modernization, right? Moving to open source ecosystem, moving to the latest and greatest available developments that are there on PostgreSQL is also a modernization that you can look at it from a magnifying lens, right? So you look at it from a cost perspective, you look at it from a feature set perspective, you look at what is the parity that I could get off of them, right? And legacy databases or replacing the legacy databases is something that is paramount for most of the guys that we are here, right? We look at, hey, I am on an Oracle, and then I would look to go from Oracle to Postgres 15s or 16s. Now, I promised about customer stories, right? There are two customer stories that I would like to look at very, very closely, right? One is we know that multi-master replication is there, and then PG16 does support some of the pinnacles of multi-master replication without even having any extensions in place, right? Thanks to some of the development that PG Logical had done, some of the logical replication improvements that we have pushed within the starting from Postgres 10 onwards, right? This is a peculiar case that we have seen that I wanted to share, right? So the ask is really, really simple, right? You look at the challenge. The customer says, we are heavily reliant on single cloud service provider, right? CSP, that's the abbreviation for cloud service provider, right? And whenever that cloud or that specific CSP's region or an availability zone having an issue, we are having a significant risk of disruption, right? And then the next challenge is limited flexibility and how do we look at from a cost perspective, right? If you are struck with one cloud, right? If you are struck with one service, not only a cloud, right? Now you look at it from a multiple dimensions, right? Cloud is one dimension, right? You look at commodity hardware as one dimension. You look at on-prem database servers as one dimension, right? All of these dimensions are set of the challenges that we have got. So what we had from a solutions perspective is, why don't we look at multi-cloud deployment, right? For us to do multi-cloud deployment, what are some of the very, very important or the foundation stones for us to have multiple database primary servers in each and every cloud that we are going to be provisioning, right? That should be the first stepping stone, I would say, for us to look at multi-cloud and then stepping into the ecosystem of solving the cloud concentration risk, right? And then some of the solutions that we have got, right? We wanted to look at, we wanted to work with customer and say that the customer would like to be in the Postgres ecosystem itself, right? Be it Postgres supported, nope. Some things like Cockroach or Yugabyte, which says Postgres supportable, right? The binaries aren't supportable, but it is Postgres supportable, right? And we also looked at some of the other solutions, like I'll be talking about pgEdge a bit, right? pgEdge platform, which is an open source multi-master replication system. And another part of the solution is how do I distribute the load across multiple clouds, right? Multiple clouds which have got which have got different sets of services, right? Different set of specialities that we have got, right? And the other main pivot of the whole solution is to mitigate the cloud concentration risk, right? And the last is how do we remain operational even when the entire cloud, right? Even when the entire cloud region is going for a toss. As in, is it down or any kind of an issue? So if we sum up the challenge and the solution, right? So we have, okay, I would like to go ahead and mitigate the cloud risk, and then I would like to have a solution in place. The solution that we have had is pgEdge platform, where it's a pure Postgres, 100% Postgres, and a completely open source software that is available, which complements the native Postgres or the community Postgres that we have got, right? And what is the outcome that we had seen, right? The major outcome is you are able to set up services, you are able to look at some of the performance. So we picked up what is the best of the lot, right? So we picked up Azure has got some of the super fast disks that we have seen, at least with our experience, right? You could see some of the performance benchmarking that Mark Wong from the community actually goes ahead and publishes on Hackers List or on the performance list, right? So we have done these analysis, and then we picked up the best of the worlds, right? So one is picking up the whole storage from an archival standpoint on the Azure. And then we have got multiple EC2 instances on AWS, and we picked up Google VM. So the whole ecosystem of building the multiple servers, multiple primary servers and multiple masters across these clouds was the first and foremost outcome that we were able to achieve, right? With that, high availability came in, right? So high availability from a 4 nines standpoint, right? 99.99%. Nowadays, people look at any database availability. Somebody go talks to a database administrator and say, what's your database availability? If it is not 3 nines, you are looked at it as like, oh, okay. What are your challenges? How do we go ahead and make sure you get your systems from 3 nines to 4 nines availability? Okay? And then from a cost efficiency standpoint, we looked at, okay, what are the cost aspects we have, right? So how do we reduce the cost with the whole challenges, right? So the heavy reliance on the CSP's special services, right? So heavy reliance on, say for example, if you are in an AWS ecosystem, your whole integration can be done pretty easily with few clicks, right? So you wanted to pick up the best of the worlds. So you are looking at integrating your Azure, you are looking at integrating your Google GCPs, and also looking at some of the other CSPs like DigitalOcean and stuff. And how did we even formulate a strategy in place? Right, this is one of the ways we have. Right, so one is the Postgres pgEdge distributed Postgres, right, which is on the open source model, like I said. Right, this is on a Confluent license, which is not the exact Postgres license, but the source is available for us to download for free and look at it, right? The entire Postgres pgEdge Spark extension is built on the native logical replication. I don't know how many of us are aware of BDR1, 0.9, BDR1 and 2, right? BDR1 was, no, I see a few hands, thanks. BDR1 was a completely open source software that we released in 2012, and it was prevalent in the market till 2016 and 17, right? The BDR1 had a lot of issues. So what pgEdge had done is picked up the source code of BDR1, enhanced that, and then put in a lot of PG Logical's magic with it, right? And we were able to look at it from an asynchronous logical replication standpoint. The whole building blocks of pgEdge platform is the native logical replication that we have got with Postgres at this point of time, right? Postgres community version at this point of time. The only addition being the Spark extension that is coming in, right? Apart from that, what are some of the limitations that we have had with Postgres' multi-master application or with logical? My colleague Lahari will be talking about a few of those cases, like DDL replication is one, right? So DDL replication in logical replication doesn't work. So we are looking at it. How do we resolve some of those issues, right? I'll not go into that piece now. But what I would look at is the support for high availability and ultra high availability, right? That's one thing that pgEdge supports. So the difference between high availability and ultra high availability is to make sure you have the additional lines being added to your whole availability, right? So you start at 99% availability, 99.3, and at some point of time you reach 4 nines of availability. Right. This is the second customer story. I mean, again, I had put the foundation around what the high availability is, and then how important the high availability is, as a matter of fact, right? So look at the challenge here, right? So the whole motive or the customer's requirement is very, very simple. I need a database which is HA, and then I need a database which is 4 nines available, right? And then downtime or data loss was never an option, because this is a financial institution. BFSIs we consider BFSIs as dinosaurs because they use a relatively older technology. They relatively use legacy systems in place, right? But it is changing at this point of time, right? Now we are changing them at a very, very brisk pace, right? The whole solutioning that we have here is, again, right, looking at multi-master systems and making sure all of the availability reasons that you are setting up, right? All the availability reasons. Let's say, take an example of AWS. You would look at setting it up on West Coast, East Coast, and then making sure you have another server or a system up and running, right? That's the multi-master system that we have in place, right? And from a maintenance standpoint, right, most of our DBAs are aware of maintenance activities, right? Maintenance activities like doing a minor upgrade, doing a major upgrade too, right? Say, for example, you are coming from 14 to 16 because 16 has been pretty stable in the market, right? So for us to do the whole activity, right, with logical replication, the downtime could be as minimal as possible. The downtime that we can see is making sure the PG bouncer is not talking to PG14, but it is talking to PG16. But with multi-master replication, what we could do is, it is agnostic of the versions, right? Starting from 14 onwards, right? If you are on a 14, you will be able to do a major upgrade from 14 to 16 without even having that downtime, right? So we say zero downtime upgrades, right? Zero downtime major version upgrades, right? So we call it as MVUs, which is nothing but the major version upgrades in the PostgreSQL, right? And then what is the outcome of the whole solution that we have built for the customer, right? It is looking at uninterrupted services, obviously, right? So we have got so many masters to play with, so many primary servers to play with, and then the connection concentration layer that we also built, right? Thanks to PG Bouncer plus HA proxy integration, right? So we are able to look at doing that connection concentration layer and making sure the application is not aware of which database server I am hitting, because all the servers that are part and parcel of your cluster entities are all taking reads and writes, right? And from a scalability standpoint, if we look at scalability standpoint, adding a node, right? Adding a node which is available, in a region, or say, for example, you are currently, your cluster is set up in 3 availability zones, right? For you to add a system, right? So previously in, in conventional physical streaming replicas, you just go ahead and add a lot of, just take a PG base backup and then your replica is up and running depending on the size of the database, right? But those database instances are still replicas, right? For you to have a system in place where you can connect the whole, new system, right? And then, add that cluster entity and then make sure you are up and running and then, writing and reading data right off of the bat. That's the, that's the way I look at HA, and then that's the way I look at scalability as, adding nodes and stuff, right? There are other scalability models which we are not discussing at this point of time, but my notion of looking at adding nodes is more of how do I make sure I am able to add, or am I able to add another region of AWS and then make sure my entire cluster has got that new instance up and running. Right, so these are some of the pictures, right, I have had where low latency is something that, we often say, hey, my application is across, multiple global regions, right? But we've got only one primary server to play with, right? All the requests that are coming from, either Stockholm, or if you have your, primary server, set up in the US, all the requests have to come down there, and then, that's how your whole, application processing happens. With Postgres' pgEdge Spark extension and the replication, the multi-master replication, you are able to do multiple writes at any point of time, right? Depending on where the server is, where the user request is, we are able to find the nearest node, route all of those connection requests to that nearest node, and go ahead and set up your data processing, right? That's the whole ball game of how are we changing the closer to the user concept. Again, right, so this is the point that I was trying to make, right? All the orange nodes are my read-write nodes. For us to have a completely, ultra-high availability model, right? So what we would like to have is, with the primary servers, right? With the primary servers, you are also setting up read replicas also. Which read replicas, now in case of any incident, where the primary database goes down, that whole instance is able to pick up and process the data, and your cluster is still available for the application place. Again, now keeping the data residency is, you look at converting or categorizing your data into native to your own country, native to your own region versus the global data, right? So with pgEdge platform, you will be able to go ahead and set up those PIIs. You'll be able to go ahead and set up which part of the data is globally identifiable, which part of the data should be residing only in that specific database node or that specific database instance. Again, right, look at the amount of computing power that we are setting up, right? What is in the Sydney, what's in the Dublin versus the DC areas of servers. Right, apart from, whenever we look at the multi-master use cases, what are some of the other, cases that you can take a look at, you can take a stab at, right? So application compatibility with asynchronous logical. One of the pain points that we have seen with each and every customer data discoveries is more of looking at how the sequences are handled, right? How your whole sequences are multi-node aware and then multi-master aware, because most of the cluster entities will be writing and then having their own sequences. One of the resolutions that we have is to look at Snowflake sequences, again, which is another open source project that is Postgres licensed, right? And other components like looking at open versus proprietary databases, right? Oracle Golden Gate does support multi-node, right? Multi-master, but we're not looking at it, right? So we are looking at an open source solution for us. I will go ahead and look at summarizing this and then take up any questions on this pretty interesting topic. Yeah, please go ahead.
Thanks for this wonderful multi-master solution that you have built. So while you are talking about zero downtime updates, which pgEdge accomplishes, right? So means like we can't expect any transaction failures in this case. So zero downtime. So the business continues to perform even when one of my node is getting upgraded. So the transaction flow will not get affected. So in this case, the transaction means do we say to the transaction that you need to reach to this portion in another region which is not yet upgraded, but while it is reaching to the host that is getting upgraded. Means in simple terms, will the transaction flow knows to which instance it needs to drop while this main instance is getting upgraded, or like one of the masters is getting upgraded. So is that the case which is happening?
Yes, it is possible. With pgEdge, Pocket is possible. So what we are looking at is more of the transparent application failure. That's one, right? TAF, right? Second is because the whole extension is agnostic, right? Agnostic starting from 14, 15s and 16s, and there is support for 17 also, right? See, whatever the data that you are writing from your 14 is eventually consistent and synchronized to your 16 instance, which is the new node that you are setting up, which is your candidate for upgrade node, right? So all of that transaction is automatically taken care by Spok's conflict resolution place.
Thanks.
Okay, close.
Yeah, couple of questions actually. The first one is this is basic replication, so I understand that no consensus algorithms like graph or access would come into picture.
Correct.
But so how do you actually deal with the conflict resolution? So in multi-master, let us say concurrent transactions happening which are touching the same page, right? So how do you actually do with conflict resolution? Maybe both the nodes would say, okay, I'm done, and they go ahead and commit. And
So-
it's an asynchronous replication, right? That's the first part. And the second one is whenever you have scenarios with network partition, right? So how do you say a read to a reader that okay, this master contains data, so you shouldn't be serving any of the data from the master which got network partition, right? So how do you deal with those kind of scenarios?
First part of the question is pretty easy, right? So we use last commit wins as the default conflict resolution model, right? That takes care, I mean, in most of the cases, right? There are quite a few corner cases that we have identified and then we are working on fixing them. But most of the cases, last commit works for us at this point of time from a conflict resolution standpoint. The second part of the question, I would have to look at a more, it requires, a discussion and, kind of a whole stuff, I would say. I cannot answer this at this point of time, the second point, but first point, yeah, first part of it, yeah.
Okay, first one also, the order of the transaction matters, right?
Right.
Last commit wins is fine. So ultimately, if you say that both of the transactions effect would be reflected everywhere, that's okay. But if I have, for example, I'll take a simple example of doing a conditional update. If my balance is greater than 0, the classical example I take, right? So if my balance is greater than 0, I'll do a transfer from account A to account B, right? So at timestamp T1, when the transaction starts at two nodes, right, two masters, the balance is greater than 0. So both of them goes ahead and transfers the amount from A to B. First one is transferring from A to B, second one is transferring from A to C. Both of them start assuming that the balance is greater than 0, right? Both of them commits because it is asynchronous. You are not taking consensus of the second master. So how do you actually undo the transaction? One of the transactions definitely needs to be undone.
Right.
Right? So, but at the same time, you are going ahead and committing, acknowledging back to the user and saying, yes, the transaction is completed and your update is successful.
Right.
So, how do you actually deal with those kind of scenarios?
So there are a couple of patches that we had done, on top of the Postgres community, right, which is from a conflict avoidance standpoint, right? Any of the cases, say for example, right, this table having couple of columns where we have a scope of updating, right, updating from both the nodes, we go ahead and set up log old values, right? That's the actual patch which we wanted to get into 17, which we are again pushing to 18, right? The log old values is what we will help, it will help us or the help Spock managers to make sure which transaction needs to be rolled back. That's the whole ball game that the Spock manager takes care by using that log old value. I mean, in the interest of time, RK, so we will look at other questions too.
My question was also regarding that.
Yeah, again, Spock manager and the Spock workers are the ones which keep a tab on which transactions have the latest commit origins, right? And then with the last commit wins algorithm, the transactions will be taken care.
And on one of the slides, if I'm not wrong, I read configurable conflict resolution.
Correct, yes.
Curious what that means.
So, if you are aware of, say, RK had mentioned about something on, these are the two tables and the columns where the currency is getting updated, right? So you have your own provision of writing whatever set of routines, right? Say, I would always prioritize my node which is in the IID, right? Which is DC. Or I would like to prioritize always the transactions that are coming from the West Coast, right? So you have that configurable conflict resolution that you can write.
So again, basically you prioritize a specific master to always have.
Correct.
Okay, that's useful.
Good. We have time for one more question, one last question. Yeah. Probably we can catch up offline and discuss. Yeah.
So you mentioned about asynchronous replication, right?
Right.
And you also mentioned asynchronous. So how do these two things work together? So give me an example that your node 1 fails. Your node 2 needs to be promoted as soon as possible.
If you look at the customer case study 2, that would answer the question.
Yeah, but then because it is asynchronous, you have a chance of losing data.
Right.
During the failover.
That's the question that this gentleman and RK also had. So we can talk about it offline. You good? Right. Thank you so much, folks.